Hi you guys, it's Miss Pruitt, and I wanted to make different videos for every problem that we were working on today on this worksheet. Concepts worksheet 3.6b, graph sketching using derivatives. And we're going to start with number one. Number one says sketch a graph of a differentiable function. Remember, differentiable means it's continuous, has no jumps, gaps, asymptotes, or anything like that. Sketch the graph of a differentiable function, f of x, over the closed interval -2 to 7 inclusive, where f of -2 equals f of 7, which both equal -3, and f of 4 equals 3. It says the roots of f of x equals 0 occur at x equals 0 and x equals 6. And f of x has properties indicated in the table below, and the table below will be on the next slide. But I do want to sit here and talk for a moment about what's going on here. That's my interval. So my graph is not going to go past -2 and 7. Also, this part right here is telling me that f of -2 equals -3. This is telling me when my x value is -2, my y value is going to be -3. Or in other words, it's just the ordered pair, -2, -3. That is all that means. And same thing, f of 7 equals -3. This is telling me what my x value is. This is my y value. So it's saying that when x is 7, y will be -3. I can also see that's telling me f of 4 equals 3, which means I'm also going to have a point at the ordered pair for 3. Roots. Roots are the same thing as x-intercepts, or zeros. It's telling me that these occur at x equals 0 and x equals 6. Or it's giving me 2 more points. It's telling me that I'm going to have a point at 0, 0 and at the point 6, 0. So it's all good because I'm going to be able to start with all 5 of these points. But now let's look at what the table is talking about. It is giving me different intervals and different important points on my graph. And it's telling me what's happening with the first derivative between those different intervals and what's happening with the second derivative in all those intervals. So if your first derivative is positive, that means your original function is going to be increasing. Sorry guys, it's supposed to be an arrow. So moving across from there, so between the points -2 and 0, my original graph is going to be increasing. And between 0 and 2, again, I still have a positive right here. Putting this note for myself to let me know that my original function will be increasing. Still, again, increasing. But, and the interval between 4 and 7 is negative. So that's going to be decreasing. So I'm getting an idea of what's going on with my graph. Let's move down to the next row where it's talking about second derivative. It's telling me that in between -2 and 0, my second derivative is negative. So that tells me that my original function is concave down like a frown. If my second derivative is positive, it is concave up like a cup. I'm going to keep going, concave down and concave down. So the point of doing this on my table is just to give me an idea of the graph that I am going to draw. I do notice a couple of things here. I notice that I'm going from negative right here to positive concavity. Anytime that happens, or where that happens, that is a point of inflection. It's where your graph changes from concave up to concave down. And I notice it happens again here. So it's either way, concave going from positive to negative or negative to positive. You will have a point of inflection. So now I'm ready to start with my graph. So kind of what we did in class today, I looked and saw across this table all of the important points that I need to look at, like -2, something's going on at -2, 0 is something that I need to look at, +2 is something that I need to look at, +4 is something that we need to look at, and +7. These are all very, very important points on my graph. So I'm going to go to my graph. I'm going to break it up. I'm going to put these vertical lines at those points, breaking up my graph so I can tell kind of what's going on in between them. So I also said +2, so I'm going to put a mark right there. Also at +4. And also at +7. Alright, you guys. So let's try to figure out what is going on with this graph in between those points. So, going back to our original slide that I had, there were some very, very important points that we needed to take note of. One of those were -2, -3. Another one was +7, -3. Also 4, +3. 0, 0. And also 6, 0. So what I want to do is go ahead and plot those points. Pick a different color. So I need to put a point at -2, -3. -2, -3. I also need to put a point at 0, 0. Let's see, I also need to put a point at 6, 0. I also need a point at 4, 3. Uh-oh. Well, that was right. 1, 2, 3, 4, and 3. There we go. And at, what else am I missing? 7, -3. Awesome sauce. So let's go ahead and try to use the things that we had here, the different behaviors that I know what's going on with my graph, negative and negative, and let's go and try to graph those curves or sketch those curves. So between -2 and 0, my graph should be increasing and concave down. The way you draw something that is increasing and concave down is like that. Next, I should have between 0 and +2, my graph should be increasing but concave up. So the way that you draw something that's increasing and concave up, kind of like that. Between 2 and 4, my graph should still be increasing, but it should be concave down. It's still going up, but it's kind of curved, like that. Awesome. And from 4 all the way to 7, it is going to be decreasing and concave down. So you should have something that looks like that. And that's how you sketch a curve, only given the characteristics and a table.